So a scatter plot, we have this graph. It has a bunch of points on it. And the reason there's points on it is because that scatter plot is actually showing the relationship between two sets of data. So if we wanted to compare your quiz scores, we just entered some quiz scores. If we wanted to compare your quiz score with how many hours you spend doing math each week, we would be comparing, is there any relationship between how much time you spend doing math and how well you score on the quiz, or how poorly you score on the quiz? So do you think there could be any relationship between those two sets of data? What do you think? Do you think there could be any relationship? In other words, maybe we could look at it this way. If you spent more time doing your math and studying it, do you think you would get a higher quiz score?
Yeah.
It seems likely that's what should happen, right? Because we're not all born to be just natural mathematicians. We have to work at it. And some of you have something that you don't have to work at very hard. It just comes natural to you. And others of us have to work really hard at that same thing. So when we are working with a scatter plot, we're comparing two sets of data and we're saying, do they have any relationship to each other? Can you give me an example of maybe a couple of data sets that might not have any relation to each other? Anybody in here like pickles?
Pickles. I like pickles.
Okay. So, pickles. Let's talk about eating pickles.
Okay.
The more pickles you eat, the faster you walk. Do you think there's a relationship between those two things?
No.
Probably not. Probably just because you eat pickles probably doesn't make you a faster walker, right?
I wish that was true.
So if we did gather some data on that though, if we gathered data on how many pickles you like to eat in a, let's say in a week, okay, you'd say, well, you keep track of how many pickles you eat in a week, and then we time, how fast you typically walk, going down the halls, going from class to class, and we compare those sets of data. What do you think would happen with the points on the graph?
They would be horizontal.
They'd be horizontal? What do you think, Trey?
They'd be scattered.
Yeah, they'd really be scattered all over the place. They'd really just be scattered all over that graph because there would be no relationship between the two. But remember, let's go back to the quiz score one. If you study more, so as the study time increases, so does the quiz scores increase. If we would show that there was a relationship between them, what would happen with the points then, do you think, on the graph? Trey?
They'd be closer together going up.
Yeah, they'd be a lot closer together and they'd be climbing, because as you move across the graph, as one thing is getting bigger, so is the other getting bigger. So that's what scatter plots are about, is comparing the relationship between two data sets. If we have positive correlation, or in other words, correlation means, do they really have a relationship? And then what kind of relationship do they have? Positive correlation says right here, and I want you to underline this, please. I want you to show if you have positive correlation, as one set increases, the other increases. Let's put boxes around increases. So if both of them are increasing, we would say there is positive correlation. The graph, the points would be rising, going up from left to right. And notice in this graph, those points do kind of form a pattern of a line that's going up from left to right. The points aren't all over the graph. They are kind of clumping together and forming a pattern. Well, when we have negative correlation, we're saying there's still a relationship. Or in other words, when you look at the points on the graph, we see kind of a pattern going on. We see the points kind of clumping together. So when there's negative correlation, so let's underline negative. As one set increases, let's box that word increases, the other set decreases. So as one's going up, the other's going down. So as we move across the graph from left to right, that's really good going up. That's increasing. That relationship, that data set, is increasing. But as we move across the graph with that increase, the points are going down. That thing is decreasing. think you can come up with an example of a relationship where something would, as one thing increases, the other would decrease?
Plants.
Pardon?
Plants.
Plants.
Like give like one water and one no water.
Okay.
On the side of it.
Okay, we gotta be kind of like doing, so we're comparing watering to not watering. So as you give more water to a plant,
It go up, like it'll grow.
it would grow more.
And then if you don't like wither anything down.
And if you don't give it as much water, its height would go down. We would not really be able, we would not really be able to compare that just on the scatter plot, okay? We would have to compare that a little bit differently. How about this? The more you go through Olive Garden, in the lunchroom, what happens to your balance?
The higher it
The
goes.
lower it goes, doesn't it? So the more you go to Olive Garden and load up on all those little spendy treats, your account decreases. You gotta start begging your parents to put more money in again. So as one is increasing, the other is decreasing. Okay, and then no correlation. Let's underline that. No correlation. None. No relationship between the sets. No relationship between the sets. The pickle one. The more pickles you eat, the faster you walk. Pickle eating affects walking? Not really.
Is it true that jalapenos are healthy?
That pickle, I'm not sure about whether they're healthy for us or not. They have a lot of salt, that's all I know.
Jalapenos?
Okay, so let's look at this one right here where they've already answered it for us, but it says, identify the correlation you would expect to see between the number of grams of fat and the number of calories in different kinds of pizza. So they're kind of like comparing grams of fat and the number of calories, and we're talking about in pizza. So as the number of grams of fat goes up, what would you expect to happen to the calories?
Go up.
They'd probably go up too, wouldn't they? Because fat grams means
Calories.
more calories usually. So in this one, we would expect it to have a positive correlation because as we increase the amount of fat, also increases the calories. Positive correlation. As one increases, so does the other. So what would we expect the graph to do then? Would the points be all over, or would they be clumping together? Rows? They would be, yeah, they'd go up. They'd be kind of clumping together and have a rising pattern, wouldn't they, from left to right? Okay, so now we're going to do one here without, we're going to practice on our own without them giving us any clues. Identify the correlation you would expect to see between each pair of data sets and explain, just like they did up there. The number of knots tied in a rope and the length of the rope.
The length of the rope, if it's not, let's say the length of the rope is like 20 feet.
Okay, let's say the length of the rope to start with is 20 feet.
If you cut part of the rope off, you
No, but we're tying knots in it. We're not cutting it. Remember?
The more knots you tie in, the shorter the rope will get.
So the more knots you tie, so let's do that. The more knots tied in the rope, the shorter the rope gets. So the more knots you tie in a rope, the shorter the rope gets. So we're really talking about
Negative.
the more knots tied in a rope. Is that an increase or a decrease?
Decrease.
More knots tied in a rope? So if we showed the knots, how many knots are tied on the horizontal axis, as we tie more knots, that's increasing. So we would say, so we have increasing knots and decreasing what?
Length.
Length. So what kind of correlation are we going to say this one has? Negative correlation, yeah. So you don't get to just say what kind of correlation, you have to spell it out why. You gotta make sense of it. Anybody got questions on that one? So again, we put the number of knots tied in the rope on the horizontal axis, and we put the length of the rope on the vertical axis, the y-axis, as we tie more knots in. So in other words, the rope is its longest when it doesn't have any knots in it, right? It's up here, it's longer. But you tie a knot in and it gets shorter. You tie another knot, it gets shorter again. You tie another knot, it gets shorter again. So can you visualize this on your map? How about the height of a woman and her score on an algebra test? The taller you are, the higher you score on an algebra test.
Yeah.
Or you could say it like this. The taller you are, the worse you score on an algebra test. Or you can say, you know what? Height does not affect test scores. Which one do you think it is? Mia?
No correlation.
No correlation. Yeah, we would say this one has no correlation. And we're going to explain why. We're going to say a person's height, a woman's height in this specific case, a person's height, and we can't be certain, so we say should not. We don't believe it would, in other words. A person's height should not affect the verb, affect a. A person's height should not affect their algebra test score. If your height did affect your test scores, you don't sign up. If you're tall, you only sign up for those, you get those you can deal once you come to school. Shorter people would say, well, I'm not going to make it anyway. I'm going to stay home. Does that make sense?
Yes.
Well, Trey, you'd be in school.
I'm lucky. I have to definitely up on this one.
Okay, so let's look at the next one. Describe the correlation illustrated by each scatter plot. So you look at the behavior of the points, and you say, I think it looks like there could be correlation, or there could not. And if you think there is, would it be positive or would it be negative? What do you think about this first one, number 3? What are we comparing here, first of all? I can't read it. What's on the x-axis? What are they comparing?
Percent on time arrivals.
The x-axis.
X-axis.
Oh,
Rose, try to get it louder for me.
Mishandled baggage per 1,000 passengers.
Oh, mishandled baggage per 1,000 passengers. Oh, so you fly and you don't get your bag when you go to the baggage pickup. So mishandled baggage per 1,000 people. What's the other data set representing? What's going on, Isaac?
percent on time arrivals.
Percent on time arrivals. Oh, so they're basically saying here, let's also use our own judgment as we kind of look at this graph and evaluate. Do we think the number of times somebody doesn't get their baggage is affected by the on-time arrivals?
Yes.
Yes.
Yeah.
So as the number of baggage, mishaps happens, as that increases, what should happen to the on-time flight arrivals?
Decrease.
They should go down, shouldn't they? Yeah, in other words, the flight's not coming in on time more and more and more, and then there's more bags. And so what kind of correlation do you think? Do you think there's correlation between those two?
Yes.
Absolutely. Those people run out of time. They got all kinds of stuff to scramble and do. So what kind of correlation is going on here?
Negative.
Negative.
Yeah, this is negative. The points are actually falling from left to right. And they're, it's really hard. Sometimes you look and you're like, but they kind of look scattered all over the graph. If you can kind of do this, draw a box around the points like that, you could say that that's got a pattern going on. Great.
But
Wouldn't that be hard because usually these people
Well, no, if you can't decide, well, it is hard to, I will agree with you. Sometimes hard to tell if there's a pattern, so then that's why you have to start using also your judgment as to, does it make sense that as the number of bags that gets mishandled increases, the number of on-time arrivals decreases, and that makes sense, doesn't it? So yeah, sometimes you have to play the two together. So good observation, though, Trey. Number 4. What do you think about that one? Is there any correlation? And you think it's positive correlation?
Yes.
Okay, let's justify it with what's being compared. So what are they comparing here?
My femur's length and height.
Okay, the height of the,
Femur burn.
no, the femur. What is a femur?
Looks like.
It's like a little rat thing.
No.
It's where your leg.
That's all.
It's like
It's a bone in your, yeah, it's a part of your leg. It's a bone in your leg, actually. Okay, so basically we're saying that the taller a person is, the longer their femur bone is.
Yes.
And that makes sense, doesn't it? The taller you are, the longer your femur bone should be in your leg. So we are going to say that yes, this one appears to have, and it makes sense that it would have positive correlation. So yes, there is an animal that's kind of close to being a femur. That's not what it's called, I don't think. Okay. Oh, what? A lemur. Yeah, it's a lemur.
A little rat things.
Okay, let's go to the back side and see what we're doing back here. Okay. Now we're talking about when we have points that we cannot connect the dots with a nice straight line, we still can draw a nice straight line going through the point, through the pattern, but that straight line does not have to touch all of the points. We just call it a trend line. It is showing us the trend of what is happening between those two data sets. Okay? And then after we draw the trend line, we can use it to make some predictions. So I'm going to hand out some rulers because we're going to draw some trend lines. And when you draw a trend line, you absolutely need to use a straight edge. If you freehand it, you're going to have a not so good trend line. Okay? So let's make sure that we use something as a straight edge when we do our trend lines. I'm going to leave that top one for you to study on your own because we're kind of running out of time here. Let's use these for what they need to be used for. Right now, we're not using them, so put them on the table. Okay. The scatter plot shows the relationship between the engine size and the city fuel economy for 10 automobiles. Does it appear, first of all, that there is any relationship between the two? In other words, is there any correlation going on here? What does it look like?
Yes.
Yes. Okay, let's look at the things that, remember it says, so this would be engine size. The larger the engine, city fuel economy, so this is miles per gallon. So the larger the engine size, how does that affect gas mileage? What happens? The bigger your engine, anybody know what happens?
The more gas.
The lower your gas mileage is. So those of you that are driving a nice little compact car, it doesn't have a very big engine in it, it probably can't, get up to speed as fast, but it's getting you better gas mileage. Those of you that like to drive those big, trucks, are they getting good gas mileage?
I drive a tank.
They're powerful, but they're not, right? They're powerful, but they do not get good gas mileage. So does it make sense that the larger the engine size gets, the lower your miles per gallon goes? So this is actually showing negative correlation. These points are falling from left to right. So what we're going to do is we're going to draw a trend line through them. So what we're going to do is, remember the trend line does not touch all the points necessarily. It doesn't have to touch any, in fact. Here's how we decide where the trend line should go. It needs to go through about the middle of the points. So there should be about as many points above it as there are below it. And trend lines they're kind of tricky. You draw one and then you start counting the points and you're like, oh, I got 7 on one side and 2 points on the other side. Is that the middle? No. So then you erase it and you try it again. Okay? So why don't everybody try a trend line on their own? See, I'm already erasing mine.
Which is,
Yeah.
I wouldn't know whether or not you want
How do we know whether we want to go up or down? We look at the pattern of what's happening with the floor. And we also do what we just did, make sense of the relationship between the two. So remember, if one is increasing, the engine size is getting bigger, and the miles per gallon are going down, would that be negative correlation? And shouldn't it fall then from left to right? So that's how we help make the decision. Okay. Count how many points you have above and how many points you have below. If you have about an equal amount.
If it cuts through, should we see which one in the line is the bigger side?
Okay, if it cuts through. So what do you mean, if one of the points is on the line, which side should we count it on? Don't count it then,
Oh,
okay? So if your trend line is going through one of the points, you just don't count that one. Just count the ones that are floating above it and floating below it. And say, do I have a pretty good spot? Now, you're not going to be expert at this right away, trust me. And we are going to let the graphing calculator show us how to put good trend lines in the next couple of days. But today we're just practicing trying it on our own. Okay, so does everybody think they have a pretty good trend line drawn? Now you have to hear me on this next thing, okay? You have to hear what I'm saying. You're going to use your trend line to answer the next questions. Okay, you have to use your trend line. Okay? So, remember how we said, given a certain x value, we can go to that on the graph, we can follow it up to the line, and then we can see what the y value is that goes with it. So I'm going to show you with mine first of all, and then you are going to use your trend line to get it. So our first one says, based on the relationship, predict the city fuel economy of an automobile with an engine of 5 liters. So watch me now. You're not going to write the same answer I do. You're going to do your own. Watch what I'm doing. Dakota? So I'm going to 5 for the engine size. I'm following it up to my line, and I can even put a little point there if I want, and I can erase it later. And then I'm going to say, okay, now where that point is on my trend line, I'm going to follow that over, and I'm going to see about what I think the gas mileage is. So according to my trend line, I'm going to say about 11 miles per gallon. Okay? You guys do yours. And then I'm going to erase that so I don't have it. So when I correct your papers, when we do quizzes and stuff, I'm going to go by what do you have. I'm going to look at your trend line and I'm going to do it just as you had done it in the test. And it better match your trend line, in other words. I'm going to do one more with you, or actually we have one more to do where we know the engine size. Part B, it says an engine size of 2.8. Well, 2.8 is not one of our grid lines on the x-axis, is it? But would 2.8 be pretty close to 2 or pretty close to 3?
3.
Pretty close to 3. So I go close to 3 here and I say, okay, I need to follow it up and I need to go on my trend line, 2.8. I'm not on a grid line, but I'm just to the left of the grid line for 3. I follow it up to my trend line. I go across and I'm going to make my prediction. I'm going to predict about 19.5 miles per gallon. Okay, you predict with your trend line. And you have to estimate, that's all you can do. You don't know exactly, but you have to make a good estimate. If it's closer to 20 than it is to 19, then you should be estimating 19.7 or somewhere 8, somewhere like that. If it looks like it's about halfway between, you can use 0.5. If it lands on a grid line, you can use the whole number. Okay, let's move on to C. The engine size of an automobile with a city fuel economy of 11 miles per gallon. What did they give us this time?
The Y
They gave us
axis.
the Y value, didn't they? Yeah. So we're going to go to 11 on that axis. So every grid line on here, by the way, is one so I'm gonna, here's my 11 right here on the y-axis. So I'm gonna follow it over to my trend line, and then I'm gonna follow it down, and I'm gonna make an estimate what size engine that is, okay? So I'm gonna say mine is about a 4.8 liter engine. You do yours. According to your trend line. So this time we started with a Y, followed across to the line, and down to the X. Yep, we both agree on that. Yep, we can have different answers. Mia asked, if I have 4.8 and she has 4.5, can we both be right? And I said, yes, we can have different answers. Because our answers are based on our trend line, aren't they? Where we drew it. Okay, now do the last one. City fuel economy of 28 miles per gallon. How big of an engine is that? Oh, it's less than a 1 liter engine. I'm going to say it's about 0.7 liters. Okay, let's put what you want.
Really small later.
It is a small liter engine, isn't it? No. So, do they even make those, I wonder?
Yeah.
Do they? Right.
For my can, I have 0.75.
Yes, you can have 0.75. Are we labeling these though? Yeah, make sure you're labeling them also. Okay. So let's be done.